Hi guys, good morning. So today we are here to study about the double wall ventilation pipe system, the fuel gas supply system for dual fuel engines. The one that I'm doing is a MEGI engine. Most of the ships with dual fuel will be pretty much the same setup. A few components here and there would be slightly different, but let's look at this one so you can use this as your base reference to learn and see what the double wall ventilation pipe, how it looks, and from where it starts, what air is in the double wall pipe, how does it reach the engine room, and after going in the pipes, where does it go? Does it go to the engine? Does it go to the atmosphere? Got this diagram set up, so please have a look at this. In fact, I'd suggest that you pause the video, take a snapshot. When we refer or when I speak about the things, you guys should know what I'm talking about. Once I explain this diagram, I'll take you down to the engine room, take you down to the deck. Let's do this then. The diagram looks good enough, so let's rock it. The diagram, basically you need to understand. First part, that side in this black outline is in the CMR, the cargo machinery room. In that, there's something called the gas valve train. I'm sure you've seen the previous videos. In that, from the fuel gas supply system comes to the gas valve train. We're not talking about the fuel, the gas from engine to now. We'll be concentrating basically on the double wall pipe. What's outside? Inside of a double wall inner pipe is your fuel, and on the outer side is your air, fresh air, that will be continuously circulated. So the fuel gas there comes out from that, enters the double wall pipe that starts here. This area is the deck. Then before going into the engine room, it goes into a small cofferdam, and then after that, this whole side is the engine room. So basic familiarization. Let's do the red piping is the gas, the fuel gas. Fuel gas supplies it there. Then we have a gas valve train that after that comes out, and the double wall pipe starts outside the cargo machinery room. Fuel gas coming out of there, ethane, 380 bar, 45 degrees, gas, remember, gas coming in, a double wall pipe, cofferdam, into the engine room. There's a loop, and it goes into the gas block of the first cylinder, and from the first cylinder, it is looped to the other cylinders by the U pipes. These are not flexible pipes, these are fixed pipes, all double wall pipes. Each cylinder head has a gas block, like I've shown here. So they are looped into a number of cylinders. The gas enters only into the first cylinder. After that, it's just looped. Let's look at the last cylinder. This is cylinder number 7, as in my case. So you can see the yellow pipes are the double wall pipes. They are linked. Their last loop, the loop ends at the gas block of unit number 7. And then the return pipe. The return pipe, gas does not go back to the cargo tank after the engine. Remember that. Gas does not go back to the cargo tank after the engine room. The return pipe is only during your start off. That is when you have to clear your lines, you have to blow off your lines, or if the gas trips, for ventilation, to just purge the lines. Okay, so the purge line also follows the same line through your engine room, through the cofferdam to the deck, and then it just goes off into a silencer and then vents out into the atmosphere. So that's your basic gas supply system. Now we'll follow the blue pipe. The blue piping is your air, the fresh air that goes into the outer pipe of this double wall pipe. Okay, so it comes from the starting air system, the main engine starting air system at 30 bar. We get it from your main air bottles, main air compressors. 30 bar is reduced down to 1.5 bar via a reducing valve on deck. This entire setup is on deck, but the pipe comes from the engine room. Then there is another valve, automatic valve. This diaphragm is activated only when the fuel gas system is, we press the start button in the engine room. These fans start, and this valve also gets the signal. Otherwise, you'll be just wasting compressed air into this. So this valve opens up. We have air going into the double wall pipe. Again, this one I will show you on deck, so remember this. So this double wall pipe starts here. Now again, this pipe, in case the pressure rises or it cannot cope up, this is a vent in the system, and all the vents on deck have vent screens. They're called as flame arresters, so that sparks don't go into the system. All of them have that. You can see them here, marked here. Okay, so double wall. Now this is still single pipe, and now it enters the double wall pipe on deck before it goes into the engine room. Remember, the gas flow and the airflow. The gas flow and the airflow are in opposite directions. Inner wall pipe goes one way, the gas in the outer pipe, that is air in the outer pipe, goes the other way. So it goes the other way around, again, into the cofferdam, into the engine, into the first cylinder gas block, and then looped to the other cylinders. And coming in out this way, out into the cofferdam, going out here. Now, this is what we need to concentrate on. Yes. Air is supplied by the system, but we need fans to keep the system continuously ventilated. So we have two fans here. They are called as double wall pipe ventilation fans. We can use either one of them. Only one fan runs at a time. So this takes suction from this side where the fuel enters. This takes suction from this side. So again, cross flow here. It takes suction from here, delivers it, and out again into a vent into the atmosphere with a flame screen. This is usually above the cargo machinery room or somewhere safe location. In this pipe, there are two HC sensors, hydrocarbon sensors in the pipe that I can get the readings on my MOP. If you remember the MOP diagram, in that we have the HC readings there. So it's pretty simple, the flow. Again, from starting air system going into reducing valve, the main inlet valve. This is the vent system. Start off, the double wall pipe starts here, goes all the way, cofferdam, engine room, loops into the cylinders, gas blocks, outlet back again, cofferdam, right up here, double wall pipe vent fans, and vent it out. Remember, the relief valve has to be there in the system in case the pressure rises for some reason or the other. This has to be there. And another thing, there are two HC sensors just located in the engine room near the gas valve pipes in the forward side. I'll show you this one down, and the aft side of the engine. So I hope this was quite clear for you guys. The flow system, the flow sequence of the double wall pipe, the air and the double wall pipe. Remember, the air in the double wall pipe is not any special air. It's just your air from your main air compressors going through entire system, and then finally it's the fans that that suck out the air and vent it out to the atmosphere. But before venting it out continuously, there are hydrocarbon sensors, two HC sensors that monitor the atmosphere of the double wall pipe. This helps us know that if there are any leaks in the inner pipe. So very important. At 30% we have an alarm, and at 40% HC we have a trip, the main engine trip. So it's a Sunday, and I hope I made your Sunday. I did make my Sunday. I like to share knowledge, and by sharing knowledge we end up gaining knowledge as well. So do shoot your questions in the comments below. Do like, do share, do subscribe. All right, take care. Cheers. The Deep Sea Man out.